Hello everyone, this is day 12 in our data science bootcamp class. In last lecture, we learned about probability. In this lecture, we'll continue with machine learning. Okay, let's get started. Anybody can help me understand what exactly is machine learning? Nishant, if you can come up with a definition for machine learning. Like what do you understand with machine learning? So your machine is learning, but how?
It's like we have a certain data set. We need to train a model to
Mhm.
on which basis upcoming data will work and give it out.
Okay, okay. It's more like
predict
you have, yes, there is
prediction and recommendations on the
prediction
basis
and
of previous
recommendation.
data it will provide the prediction or recommendation about it.
Okay, okay. You guys might be knowing this mathematical formula, let's say, where we are calculating percentage. You know, if let's say, if out of 100, 20 people are, what do I say, about age 20, then out of 10, how many would it be? Like you make well, there's a formula for this, right? And I mean, let's say after 100 is 20, 20 into x divided by 100, and that is how you get it because that's a percentage. Now that is a level of algorithm. That's also an algorithm. Like we are predicting it. There's no machine learning in it. We also have this historical data that every time when there are 100 people, 20 people are of certain age. Okay. How does machine learning is different from this particular algorithm? Is anybody like there are multiple data points, there are multiple history, past pattern, and then we are also predicting something. Give me a real world example of machine learning.
Stock market prediction.
Stock market prediction. How would you predict stock market prices?
I mean, there are certain patterns in which some chart follow the trend. Like we will, when there is a chart around about some stock, we can predict that it will go up or down.
Okay,
Certain
okay,
patterns based on certain patterns.
okay. Weather prediction, chart prediction. Is it always prediction model that is used in machine learning? Anything? Can we come up with this? Let's say you are giving an input, but the output, what you are expecting, is not always the same. You know, let's say every day, what do I say? Because of some particular action, the chart prices are moving. Now you have your parameter, and your machine is learning like out of it. Like you have all the parameters, and then it is sort of like coming up with an assumption that when certain events occur, then this will be the, what do I say, the output. So that is an example of machine learning. And this is not exactly machine learning. In machine learning, how do we how do I distinguish? Let's go up with an example. I'll just share my screen and then we'll get started. It's a simple definition. We'll get started. I did not share my screen though. Okay, it's stuck. Oh, my bad. Mm, Cool. Let's. Okay, we'll start with introduction of machine learning. How many of you are aware of machine learning? I think Krish do have some knowledge in machine learning. Nishant, what about you? You also do.
Yeah, yes, I learned. Yes.
Okay, nice. And Devesh?
Yes, I speak.
Oh, you also. Nice. Cool. Okay. So today we will be learning introduction. Okay. What we can do using machine learning. What are the common libraries? And there are different libraries, PyTorch and TensorFlow, which is something we are going to use forward. We'll understand the difference. Now, what exactly is machine learning? Machine learning is a subset of artificial intelligence. That is by definition. It is a branch of AI that focuses on creating systems that can learn from the data and improve their performance over time. So as I told you, there was this example. Let's say 20% out of 100 has certain specification. Now that's not machine learning. That's a very constant thing. But if your machine can learn, your algorithm can learn by itself that there are certain inputs, there are certain outputs. It is also making the output which you also have not thought of it. Okay, using our inputs, there are certain scenarios where which is coming out. And that is a part of machine learning where your own algorithm learns through the historical data points or the past data points, or the prediction data points, or from other model outputs. Then it is machine learning. You simply put it, machine learns by itself. It does sound a bit complex, but the patterns and outputs when it learns by itself, then it is machine learning, or else it's a simple algorithm. And it's a simple algorithm, there's a certain input, certain output. That's an algorithm, but machine learning algorithms are different in that way. It enables system to learn from the data without explicit programming. As I told you, you are not fine tuning your output as per the input. As per the inputs and outputs, it is fine tuning itself. Common application include image recognition, natural language processing. It's important. Machine learning algorithm can be categorized into supervised, unsupervised, and reinforcement learning. Okay, what can we do using machine learning? Give your homemade robot a brain, make it recognize face, learn to walk, okay? Unlock hidden patterns in your company's user logs, financial reports, and sensor data. So this is where it happens. I'll give you a real-time example. So again, in an e-commerce site, there were after a certain point, users were dropping from the website. So retention rate was only 40%. Let's say 10,000 user would visit, and out of which 40%, which is 4,000 user would go to next page. And why that would happen? Then we later realized that the color of the home page was not very appealing to them. So it was taking a full home page. There was a carousel and there was not a lot of detail. So what we did after that, we came to the conclusion that why they are not coming. So we did come up with the algorithm, come up with analysis that why that is happening, why we are not able to retain the user. And then we itself got the details from the user log that after 40 seconds, out of 10,000 users who comes through a Google link, they are not staying in the website more than 10 seconds. Okay, and they are not going to the next page as well. So that's the reason. So that we figured out using it. Segment customer to design smart personalized marketing strategy. Recommend products to user by learning from similar customer behavior. This is very important. The recommendation system that you see in, let's say, Instagram. Instagram has a very strong recommendation system, and so does Spotify. So, I mean, there are certain features that they do it. Let's say Devesh is a mutual friend to Krish and I. And what we're doing, let's say I am liking certain reels. Krish is also liking certain reels. And since Devesh is our what do I say, mutual friend, so Instagram will suggest one of our reels to them. Okay. And if Devesh is liking that or he's spending too much time, is watching it again and again, then they'll show the other like reels that I and Krish we both have liked. So it is creating a map in its algorithm. Let's say if I and Krish are liking the reel, there is a very high chance that Devesh is also going to like the reel. And somehow I am pretty sure Instagram knows that we four do a bootcamp every weekend. So if we three are liking something related to data science, there is a very high possibility that Disha would like it. So that's a very small example of machine learning that we are doing. So it's not something that is fine-tuned on our end. We are creating models that will do this for us. Okay, detect potentially fraudulent transaction automatically, forecast sale revenue or demand with data-driven prediction, automate and optimize real-world decision using intelligent algorithm. Cool. Which are the common ML library? Okay, the most popular library. The most popular library that we are going to use are list down here. Scikit-learn, best for engineers, used for regression, classification, clustering, includes ready-to-use algorithm. Okay, TensorFlow built by Google for large-scale ML. Keras contains high-level API for deep learning. Comes built with TensorFlow. PyTorch is developed by Facebook. Pandas and NumPy for data handling, because ML data can be clean. Okay, PyTorch versus TensorFlow. The difference between PyTorch and TensorFlow is, let's say, when you're starting out, that is Keras with TensorFlow is recommended. You can control for custom models, and it is PyTorch. You're working on research like PyTorch. You want to deploy the mobile to web, then it is TensorFlow. Okay, we are done with it. We have an idea what exactly machine learning is, where to use it, the libraries. Now, how the machine learns. Okay, just 1 minute, guys. We'll quickly jump into theory after this, once we are done with the definitions and our basic is clear. Today, we will be also implementing, we'll be using Scikit-learn and get started with it. Screen is not visible, right? Okay. Is my screen visible?
Yes.
It is, right? Okay. I'll quickly go through it. How machine learn. Not so long ago, if you had picked up your phone, opened ChatGPT and asked it what to do in a certain particular situation, it would have ignored. You and people might have looked at you like, what's this? It would have ignored you, and people might have looked at you like you were losing your mind. Today, it's normal. Technology is growing like never before, and machine learning is at the center of transformation. Back in the 1990s, one of the earliest real-world application of ML was the spam filter. Imagine checking your email back then. Your inbox would often be flooded with unwanted messages about dubious offer, miracle diets, or suspicious job proposal. Engineers started building systems that could learn to recognize the spam patterns and based on example, the idea wasn't to hard code the rules like if the email contains a word lottery, mark as spam, but instead to let the system learn from actual spam and non-spam emails. Over time, as user kept marking messages spam, the message learned to identify new spam even more the user had to touch it. That was early machine learning in action. Okay, got it? What machine learning is not, if you download hundreds of books on your computer, it does not automatically become smart. Your computer does not start writing like Shakespeare or summarizing those books for you. It just stores data. That's not machine learning. That's just data storage and retrieval. Machine learning kicks in when computer can improve at a task by learning from the data and experience without being manually programmed for every scenario. As I explained before, let's say you are helping your computer, your algorithm to learn through the inputs, and you are not explicitly designing the output for it. Okay, that's what machine learning is. What machine learning is? Machine learning is the science and the art of programming computers so they can learn from data. Is slightly more general definition. Machine learning is the field of study that gives computers the ability to learn without explicitly being programmed. Again, just remember this. Machine learning, it's not, you don't explicitly program things. It learns from the input and through its past data and pattern. Okay. A computer program is said to learn from experience with respect to task T. Some performance measure P. It is performance on T as measured by P improves with experience. Okay, that's fine. Let's not deep dive into it. Okay. The example used to train system are called training set. Each individual set is a training instance. The part of ML system that does the actual learning and prediction is called model. Okay. The example used to train the system are called training set. And each individual example is a training instance. That's a sample. The data is called training set. The sample is called training instance. The part of the ML system that does the actual learning and the prediction is called model. Got it? Whatever your main algorithm, which learns and predicts things, that is model. Think of model as the brain that is being trained. Some popular model includes neural network, random forest, support vector machines. Are you guys familiar with any of this?
Yes.
Yeah.
Oh, you guys are familiar with all of this?
Uh,
I lost.
the neural networks and random forest.
Is there a problem from my side?
Yeah.
Yeah. Yeah. Internet problem.
Voice is like
Yes, sir. Yeah. Can you confirm if I'm audible and visible?
yes.
Yes. Yes.
Cool. What is the difference between traditional programming and machine learning? To truly understand what makes ML different, let's compare it with traditional approach. In traditional programming, a human writes explicitly rule for the computer flow. In a programming language, you write an if else loop for loop. So that is your traditional approach. If an email contains the word free money, marks it as spam. But if spammer starts with writing free M0 any Y, then that breaks the rules. Now, what is a machine learning approach? The computer is given example data. It learns the rules by itself. It creates its own rules. There's an input, then output example, learning and model. Then new input plus model is equal to prediction. There's an input and we are marking it. Let's say this is an email, this is not an spam email. So it uh, identifies a pattern by itself. And that is how machine learning works. You are not explicitly defining the rules. It defines the pattern itself. So instead of hard coding logic for every possible spam variation, the system learns pattern in spammy emails over time and generalizing them to new messages, even ones that hasn't been before. Okay, let's start with this. Let's go with the summary. Just storing data is not machine learning. ML is about improving performance with experience. The system learns pattern from data rather than following hard coded rules. The model is what makes prediction. One of the earliest ML use case was time detection. Unlike traditional programming, ML system adapts as they see more data. Got it? Okay, I'll share the document, give access, read me access to everybody. Anyone with the link can view it. Done. So let's move ahead and let's get our hands dirty with Scikit-learn installation. Okay, anybody would volunteer to share the screen? We'll install it on that system. It's pretty huge. Pip install Scikit-learn. Let's see how much time. Nishant, if you can share your screen. Open Jupyter Notebook. Okay, we have it. Now go to Google and write Scikit-learn. Scikit. Are you familiar with it? I don't think so. Scikit-learn Python. Okay, let's go to the installation. Any library, if you want to check like how it works, you go to installation. It's a pip install program. Scroll down, and that is how you do it. Create a, because in our case, we will be using it in Jupyter Notebook, so it is going to pip install Scikit-learn. That's it. The first, as you can see in the first command, they are creating a virtual environment. They're activating it and then they are installing it. But we are doing it in Jupyter Notebook. We'll just directly install it. That is pip install Scikit-learn. No, not that one. The above one. No, no, don't run it here. In the notebook itself, like this is how we used to install it, right? You do a exclamation mark, keep install Scikit-learn, and you would be able to install it. Remove the dash, that's for universal, that's not needed. And there you go, it will be installed. Everybody please follow along and okay. Hit 3 is it? That's how you install it, right? Just do a pip install Scikit-learn. Do a pip3 install Scikit-learn with an exclamation mark. That should work. Let me check. Devesh, Chris, are you getting the same error?
The Scikit-learn, I think, may in my device already installed.
It's already installed, right? It's running. It's running. Okay, let me share my screen and do it. You should be able to do it. Okay, it is taking some time. Yeah. Okay, it's already running. Krish, did it run on your system?
No. Is
It did not run on your system as well. You guys are not getting this message. The record already satisfied or something like that.
no.
Okay, strange.
Yes.
You are getting it. I am getting it. Nishant and Krish, you have a problem. Krish, if you can share your screen, we'll check it. Nishant, you are getting the same problem, right?
Is it visible?
Yeah, it is visible.
Yeah, maybe it's already installed, I guess.
But it should see that the Scikit-learn is already installed, something like that. It should be open the terminal.
Oh, now
See, it's
it's ready.
installed.
Okay.
So it's running for you.
Yeah,
Nishant, are you getting the same message? Nishant, can you hear me?
हो गया install हो गया.
Okay.
Right.
What was the problem?
I don't know where I run in the command prompt install. I don't
Okay.
able to install in Jupyter Lab.
Okay. Strange, but yeah. Cool. I'll share my screen now. To finish what is machine learning that also we did during network prediction program. Right, tools we don't have the tool that's the summary. We install Scikit-learn now. Hmm. Now let's make our first machine learning model. I'll share the documents after we get that. Let's get started with the first machine learning model. Okay, we will be making our first machine learning model. Okay, here, can we predict if a fruit is an apple or an orange? That's our machine learning model. Okay, so the idea is we have some fruits, apples are heavy and red, oranges are lighter and orange color. So that's the idea. We have to distinguish between it can be either apple or orange. At first glance, it seems easy to tell them apart. You can always compare orange pixel and red pixel, image processing or check the weight. But as you keep getting more fruits, it becomes hard to write rules for every single fruit, and with messy real world rules you write starts to break. Let's train it with machine. Okay, let's do a code along while I am at it. You got the problem, right? We will be giving two fruits and they have to predict it is either apple or orange. We can't write a certain set of rule because apples can be of different shades of red. They can be of different weight, whereas orange can be of different shades of orange and they can be of different weight. So it is really hard for us to write a rule for it. Okay, how do we do it? Okay, let's install from visible, right? From Scikit-learn importer 3. Got it? These are the features that we are going to give it. It's taking too long to process, even in my case. It's fine, unless and until it's giving not giving an error, we'll find. Features, what are the features that we want to look for? I have the features with me. Okay. So as per the documentation, let's collect the data. We have the data. For an apple, the weight is 150 and it is red color. 170 and it is red color. 130, one is orange color, as you can see. Okay. And we are labeling it. So we are making our machine learn when the weight is 150 gram and it is red color, it is an apple. When the weight is 170 gram, it is red color, it is an apple. When weight is 130 gram and color is orange, it is an orange. When weight is 120 gram, it is color is orange, it is an orange. Got it? So we will be first giving them input and output, and we are training our model. This is the example of how we are training our model. Let me just copy paste it so it's easier for everybody. So got it. We imported scikit-learn tree, and then we are running it. These are the features, these are the labels. Okay. Now, how do you train the model? This is the most important part. Training your model. You know, we are getting a decision tree classifier constructor from the tree. I believe it's a constructor here. And what do I do? We are running a fit, calling a fit function with features and labels. Okay, this is how we are training the model. You can do it on a local system here. Take some time. And how are we predicting it? Now we are predicting it. Okay. Now what we are doing, we have run a machine learning model with this input. We have a very less number of input, so it may not be perfect. The more the input that you have, more perfect your, the better your machine learning algorithm is. What we are doing, we are predicting using a tree classifier. You know, there we are passing. The weight is 160 and the color is red. It's heavy and reddish. Probably an apple. That is, what do I say? 115 gram, and the weight is orange. Sorry, color is orange. It is probably an orange. So if we run it, 160, it is going to be apple. 115, it is going to be orange. Did you understand? We created our machine learning model just by few lines of code. Okay, it's no if else. We are training our model. If it is 150, it was red. It was 170, it was red. Sorry, 150 and red, it was apple. 170 and red, it was apple. 130 and 1, it was orange. 120 and 1, it was an orange. We labeled it. We give it the output. The first one is apple. Second one is apple. Third one is orange. And fourth one is orange. And then we are getting the input. If we want to check what we are going to do, we will switch the labels. Orange, orange, apple, apple. You know, we are switching the label. And in our case, if it is red color and heavy, it is an orange. Right now, for our algorithm, we're again running the classifier, and the output should be orange and apple. Orange and apple. Okay, got it? Let me fix it again and run it. In the classifier, run it, and we have apple and orange. Okay, now let's test our model. Okay, what does it think for a weight? Okay, give me a weight. Let's run a prediction model. Give me a weight.
180
Anybody?
and 2.
How much?
180 gram.
180 gram.
And sir, and if we by mistake we give 2, so it will be predict or not?
Let's because it's outside, so it will okay. It's still giving us an apple because see, in machine learning, it will try to give you the nearest prediction that is possible because the criteria that we have in our classifier is the weight is a bit heavy, so it is probably an apple. You know, so this is a prediction. So probably an apple, probably an orange. It's not sure. Okay, get it? Let's say if we put 0, it's again apple. It's apple because we are giving this type. Okay. The weight you're seeing, you're understanding, right? It's not a perfect algorithm or a perfect prediction. It is assuming that that the weight is very heavy, so it is probably going to be an apple. And more data you put, the more fine-tuned your model would be, the more better your model would be. I think Krish, I mean, you guys might have done this, I believe. Have you guys worked with scikit-learn by any chance?
Not practically.
Oh, okay. What theoretically you work with scikit-learn?
With the theoretical concepts they taught us.
Oh, nice, nice, cool, cool. Okay, you're understanding. You're following through what we are going. Okay, cool. Okay, please jot it down, and after it is done, do let me know. I'll paste the features and labels so that you don't have to type it out, and then we will move forward. Okay, let me know when done. My bad.
Yeah.
Done, right? Is it done, everybody?
Yes, yes.
Okay, cool. Cool. Let's move forward. Okay, I lost the document. Give me 1 minute. Somewhere in that. We tested our model. Okay, it is giving us an orange. Let's try with something else. 140. It's an orange. The weight is very near to the spot, so it is an orange. Even and the color is also set to this thing. Okay, it is giving more priority to the weight than the color, which is not a very good algorithm in our opinion. Now let's do one thing. Let's try to visualize it. We learned matplotlib. Okay, let's try to implement matplotlib and visualize it. Okay, from Scikit-learn uh, learn dot tree, we are importing plot tree. Okay, import matplotlib dot pyplot. Okay, getting okay pyplot. Now, okay, let me just copy it from here using matplotlib to visualize. Okay, plot with a figure size of 10 by 6. Okay, we want to plot a tree with our classification with weights and class. Class name is apple and orange, and it should be filled. What is the plot? Okay, this is how we are plotting it. So this is our what do I say prediction visualization, the machine learning visualization. What is the visualization if weight is less than or equal to 140? GNI is equal to 0.5. Okay, what is GNI in machine learning? Any idea, guys? Anybody?
Gini Index.
Gini Index.
Gini index.
Uh,
What's that?
Not much familiar, but
Okay, let's learn it
something
together then.
ratio type.
Let's check it. Okay, what is a okay, oh my God. Okay, Gini index, Gini imperative is a measure used in machine learning, particularly in decision tree algorithm, to quantify the impurity or heterogeneity of data set. Now we have to understand what heterogeneity is. No, it's fine. It helps determine how well a feature can be used to split data into purer subsets. The purity implies a higher concentration of instances belonging in the same class. Here's a breakdown of gene index in machine learning. Gene index accesses the probability of misclassifying a randomly selected element. So what does that mean? Okay, gene index is calculated by summing the square probabilities of each class within a subset and subtracting the result from one. Okay, now let's not get into definition. Let's understand. Like if it is higher, is it better or is it lower? It's better. For example, if a node has two classes with probability, did not write in the most efficient way. So let me bring it. Is generally computational. The graph penetrating equals to 1 start, while gene impurity only goes up to 0.5 before decreasing, thus requiring less computational power. The range of entropy is 0, whereas range of gene impurity is from 0 to 0.5 for binary classification. Mm. Now, what I want to understand, like in Gini index, how Gini Index affects my algorithm. How Gini Index affects my machine learning. Mhm. A higher, specifically at the context, generally means high level of impurity. Okay. This can negatively impact model accuracy and performance because it indicates that data points are not well separated or easily cross classified. In our case, let's say the lower the Gini index, the better is in our sample. If the value is 0 to 2, then it is class orange. If the value is 2 to in two sample, the Gini index is the value apple. So the lower the Gini index, the better is your algorithm. Okay, because we use 140 and 0. Let's do a 180 and 1. Okay, now if I run it, the classification of weight and color. Okay, when weight is less than 140, there is gene, there is an impurity. There are four samples, it is not able to understand like which could be. It could be class apple or class orange. Now, when in the two sample, if the values are 0 and 2 and 0, then it is pretty sure that the class is orange and class is apple. So what I understand by this is lesser the Gini index, the more the model is sure that what is going to be the output. If you guys disagree or you think that something else, do let me know. We'll figure it out outside. Okay, let's move forward by drawing this. I'll share it in the chat. And once you're able to plot this, do let me know. We'll continue.
Done.
This is done, right? Okay. It's done, everybody?
Yeah.
Okay. I'm sharing a link. Maybe if I'm not able to cover this, do take a look at it after the lecture. It is ML Playground. I'm planning to do this as well. Okay, these are the models, like how it works. You will be able to understand it. Before that, you do need to have a bit of basic, but just in case I forget, I'll just quickly share the link in the group that we have. Hmm. Okay. Let's quickly go through this. History of machine learning. Imagine it's 1936. The world is on the edge of chaos, but in a quiet university in England, a 24-year-old genius named Alan Turing is sitting in his room. Alan Turing, are you guys familiar with him? Father of artificial intelligence,
Yeah.
Turing test and all that. You might have studied in your computer science. Okay, not about what, not about policy. He's wondering, what if I design a machine that thinks? That this wasn't science fiction. This was the beginning of a revolution. And there's a very good movie. I forgot the name. It's one of my favorite. It's on Alan Turing as well. So it's on World War where they decodes the message which is coming from the Allied force, uh, Texas, yeah. So they were England, so yeah, which was coming from Germany, and they did use machine learning in it. So they needed a very large set of data. So he did sacrifice. I mean, one of his teammates had somebody. Have you seen the movie by any chance? No, right? I'll recommend it. It will get you interested to. Um, let me go and start. The Imitation Game. It's one of my favorite movies. You can do watch it when you get time. It's on Amazon Prime. I watched it on torrent. Set it on record. I can be jailed for this. Let's quickly share it. My what do I say? Interest for artificial learning came through that. So in 2017, I watched this movie, and then after that, I gave a presentation on AI in college, and after that, I sort of like more interested in this. Okay, you'll love it. Yeah, that's fine. Again, assumption. We are coming with a prediction that this is the output. So probably you're going to love it. So that's fine. Machine learning algorithm. But yeah, let's see. Okay. The birth of Turing machine. And Turing does not build robot. He builds an idea, a hypothetical machine, which we now calling a Turing machine. They could simulate any algorithm you can think of, given enough time and tape. Think of it like if you can explain the rules clearly enough, this machine can follow them blindly and produce the answer. It was like inventing a brain with neurons. Fast forward to 1915, can machine things? In 1915, Turing writes a paper with the boldest question of his time: Can machine think? To answer that, he proposed a test, later called Turing test. Turing test is something also you ask a certain question to your program. If it passes the question, then it has passed the question. Any idea what happens when they pass the Turing test? Okay, if they pass the Turing test, then it is artificial intelligence. It is artificial intelligence. If it does not pass, then it is not. Where if a machine can fool human into thinking it's also a human, we must admit that there's some form of intelligence. If a program passed a Turing test, then the program has an artificial intelligence. Okay, what exactly is Turing test? I think we are a bit deviating from the lecture, but it is interesting. Uh, Turing test. Okay. See, these are the, what do I say? Okay, so there's a Turing test. If you're able to, I'll again share this URL. If an algorithm is able to fool a human into thinking it's also human, then we must admit it has some form of intelligence. This moment is now seen as starting crystal of artificial intelligence. ChatGPT, it does look like if somebody sitting back on the server chatting with us. It definitely does pass the Turing test. Okay. Spoiler alert, machine did not pass the test then, but they are really getting close now. The first learning machine, 1957. A psychologist named Frank Rosenblatt creates the perception, the first algorithm that could learn from data. Okay, this is 1957. It was simple, crude, and limited, but it was a machine that could improve itself. That was enough to make the scientific world think. Perception could walk, talk, and learn like a baby. In 1957, it was able to do something pretty basic. Okay, it was oversold, it flopped, but it planted a seed and its seeds grow. Okay, that this is some one of the first instance of machine learning. In 1980s, there's a quiet comeback that has happened. The world moves over. AI became a punchline in a computer science. Funding dries up. But in dusty labs and stubborn mind, the idea of machine learning refuses to die. In 1986, researchers bring back neural network inspired by how our brain works. And this time, the model can be finally do something useful like recognizing handwriting or predicting data attacks. Still early, still basic. Considering 1980s, it was not, but uh, considering the breakthrough, it was still early and it was still basic. But machines were learning again. In 1987, this is when it happened, the deep blue. Okay, so any idea what happened during this time? Okay, a chess engine was created which was able to defeat a world chess champion, which was Gary Kasparov of the time. In 1997, IBM's Deep Blue defeats world chess champion Garry Kasparov. A computer beat the best human in the world in chess, but not only by brute force alone, but by learning and optimizing strategy. Suddenly, can machine think become a less of a joke, more of a warning sign, and we have entered the machine learning data. Now, why this is considered really important, a real breakthrough? Because chess engines were used in early 90s. It was used to predict things, analyzing data. Now it is used to an extent that you can't just defeat it. Even Magnus Carlsen, the highest rated chess player of all time, does say that it is really, difficult to beat a machine. It's almost like if you're competing in a, what do I say, hand-to-hand combat, but your opposition is a hydraulic press, so you can't defeat it because of the sheer material it has. Because when it started, the machines were not able to defeat the human, but it kept on learning, it kept on thinking of calculation. In chess, there are n number of combinations. Till today, not all the combination has been played. You move a single piece, and there are multiple combinations again. So Deep Blue was able to calculate all of it, and you could see it was. If you see that match on YouTube, you could see Garry Kasparov was visibly frustrated that he got defeated by a machine, and so that happened. So maybe I'll share a video on that as well. You would think so. It was a breakthrough, and now there are other complicated games like Go, which is a Chinese game. It has even more combinations than chess, and Go is also able to do it, able to play games, able to defeat the world champions. Okay, but how do machine learn? That's the million dollar question, right? Not all machines learn the same way. Some learn like student from labeled example. We call this supervised learning. What we do, it was a super. What we did previously, it was a supervised learning. Certain weight, certain color, it is apple. Certain weight, certain color, it is orange. We are giving them a data. We are supervising it. It's like you are telling the machine, you're supervising the machine, and you are telling that this is how it's happening. Some are explorer figuring out without answer, which is unsupervised learning. In chess, it is unsupervised learning. How it predicts. I'll tell you on a basic level. There's a rating, it combination, which tells you that if it is negative, then it's black is winning. If it is positive, white is winning. If it is zero, then there is a chance of draw. They'll draw if they follow certain rule. Now you don't supervise certain moves. Let's say if a white player is knight f3, then it's win. It has to calculate the combination. It also has to take a lot of things into consideration. You can't do supervised learning in that. So in that case, it is an unsupervised learning. Where we are not defining the features and labels. Okay, got it? Got the difference? Okay. And some are more like gamers, trial and error addicts, learning from wins and losses, which is reinforcement learning. Okay, got it? Let's say you're playing it, you're learning it. There are rewards. You can literally specify in a game. Let's say if you're winning it, you tell them this is a reward. Like if you win, this is a reward. So it will figure out its own pattern, its own algorithm. So that is also reinforcement learning. Okay, that's we'll explore the next. But remember, it all started with a question in Quite Room in 1936. Can machine think? Supervised learning. Let's go back to school. Think of your first grade classroom. You're sitting at a desk. Your teacher holds up a flashcard. On it's a photo of an animal. She says, "This is a cat." Then comes another. This is a dog. You're understanding? Okay. You're 10. I mean, it's pretty self-explanatory what is written over here. It's showing a card. Like, is this a cat? You say this is a cat. Supervised learning. The teacher is telling you this is a cat. Then they bring another picture. This is a dog. And then you're learning it. Your teacher is your supervisor, and you are the algorithm. The data is the data set, which is defined by features and labels. Okay. After the card, she shows you animals and tell you the names. You can see the picture, you get the answer. Over the time, your brain starts to figure out the pattern. Cats have pointy ears, dogs have longer snouts. You don't realize it, but you're learning it. You're understanding, right? Your teacher is not telling, see, if they have this diameter of eyes, then they're cat. If they have this diameter of eyes, then they are dogs. If there's a pointy, what do I say, ear, then they are dogs. Teacher does not specify it. You learn by yourself. You are figuring out a pattern in your head. Why is it called supervised? Because as a teacher, a supervisor, someone who tells the machine, this is the input, this is the correct output. The machine, like a student, looks at the example and tries to learn the relationship between two. Okay, it's not matching, it's just matching pattern. Okay, real world example again. Spam email is something was very revolutionary back in time, so it will come again and again. And it's also really easy to understand. Because in spam email, there is no pattern. You can write anything. Somebody from Nigerian king is going to give you all his wealth is also spam email. But like literally, your grandfather also could type an email saying that I want to give you all my wealth. You can't put it as spam. So that's risky. Okay. You get 100 emails, some are spam, some are not. You or someone mark which ones are spam. That's the label. Now you feed these labeled emails to machine learning model. It starts to notice spam emails often, then says congratulations. Doesn't notice it's again sort of doing congratulations. Now you can't write a features and label for that. Let's say that as a congratulation, then it will go to spam. Then all your offer letters are going to spam. So that's not happening. Okay. Or have a lots of exclamation mark or money. Next time when a new email comes in the model guess it's a spam based on what it learned. That's a supervised learning action. You're not providing a set of rule. You're telling them that certain emails are spam and it is creating an algorithm in its not in its head, but it is creating a pattern. Okay. Some famous supervised algorithm. You don't need to memorize this, but these are what people often use. Linear regression, it's predicting house number. I mean, this is one of the classic example of supervised learning. Logistic regression, predict categories, yes or no, spam. Okay. Decision tree, ask question like 20 question in the game, and then you make a decision. The last one is support vector machine, fancy names, draws a line between things. Okay. They all do basic job. Learn from label data, predict the label of a new data. Got it? That is supervised learning. Okay. Again, if we revise it, we have features, we have label. If you yourself, the engineers, are defining the features and the label, and you're expecting your machine will learn from it, that is supervised learning because you are supervising it to your machine. Okay. Why is it so popular? Because label data is everywhere. The doctor labels X-ray, an X-ray. This shows cancer. A user label a product review. This is positive. A bank labels a loan application. This one defaulted. Okay, it's really easy to label a data. Now, machine love that kind of help. The more labeled data example they see, the better they get. Now, when it fails, but okay, here is the problem. What if you don't have a label? What if no one told you what was a cat or dog? Just like Devish gave us an example, if it was 180 kilo and we did 2 as an output, because our algorithm did not know what 2 was. It only is familiar with 0 and 1. So at that time, it said that it was an apple, which was not correct in that case. Okay, then machine in on its own, it's a whole different style of learning, and it will cover in the next lecture. Okay. Supervised learning is like a student with a stack of flashcards and a teacher by the side. Watch, learn, practice, repeat. This is how machine humans get smarter. So got it? Any doubt in supervised learning? It's a basic definition. We also did an example using Scikit-learn. Okay, let's get into it. Unsupervised learning. Okay, imagine this: you are dropped in a brand new city, no guide, no map, no translator. You walk the street, look at the people, try the food, hear the language, and start figuring out on your own. Okay, it's a very nice example. You notice some people are always in suit, rushing into glass buildings. Others wear aprons and hang out around food stalls. Some are in uniform, directing traffic. You don't know the job titles, no one told you, but your brain starts grouping them. Office workers, chefs, police officer. That is unsupervised learning. Okay. No supervisor, which is unsupervised learning. You're not labeling the data, it is unsupervised learning. So what is unsupervised learning? It's learning without answer. There is no teacher, no label, no one telling the machine what's right or wrong. Okay, you just give the machine pile of data and say, go figure it out. Find pattern, find structure, group things, compress the fields. See, doing all of this, maybe let's say a decade back, would have been very difficult. But now certain libraries are in place. So let's say if you're a small business owner, if you want to figure out a pattern, you can do it. Certain questions we are not able to answer. Machine learning does help in that. Okay. Why it is called unsupervised learning? Because there is no supervision, no labels, no answers, just the data. The machine is flying blind using math and curiosity to group things that look similar, like organizing a bunch of random photos without knowing who or what it is in it. Okay. A real world example is customer segmentation. Let's say you run an online store, you have thousands of customers. You don't know much about them, but you have their behavior, what they buy, how often they visit, how much they spend. Now, using unsupervised learning, your system might group up them like bargain hunters, big spenders, nighttime browsing. It's not something we are not labeling it, but they are giving a pattern. Certain users, let's say an example like who shops at after 8 p.m., they are buying heavy, for some reason, maybe could be anything. So that you discovered through your algorithm. Now, no one gave this machine this label. It discovered them. Now you can offer deals to one group, loyalty perks to another. Smart, right? Got it? The usual algorithm, no need to memorize this again. Okay, here are some common ones. Key means clustering. Group similar things into cluster. You're creating a set of clusters of whatever unsupervised data is that. Certain age groups, certain section group, buying pattern, history. Okay. Hierarchical clustering builds a family tree of the data, dependency tree on the buying pattern or whatever. Then principal component analysis, compress big messy data into a simple form. These are just tools. The idea is the same. I don't know what it is, but let's find what's similar. Got it? Okay. Supervised learning, unsupervised learning, and then we have reinforcement learning. But before that, let's see. Sherlock was unsupervised. Think about it. Sherlock, are you guys familiar with Sherlock Holmes? I'm wondering, all of the Benedict Cumberbatch movie are coming as an example. Sherlock Holmes, it's a really nice series. I mean, it's again recommended. Okay, was unsupervised. The first season was better. The second and third, I just watched it because I expected that there would be something. Coming back, Sherlock shows up at crime scene. No one tells him what happened. He look at the clues, gathers data, start seeing patterns, and other miss. This is a classic supervising thinking. Machine are doing with the same thing, but with numbers, not footprints. Okay. Why do we use it? When we don't have a labeled data, when we don't want to discover the hidden pattern, when we want to explore before making decision, because we are ourselves are not sure. We can't label user. We have a set of data. Let's say if machine can make sense of it. That's when we use unsupervised learning. It's not always accurate, but it's insanely useful. Then again, reinforcement learning. Okay. Picture this, a small robot is standing in front of a maze. The goal, reach the exit. Maze, you're familiar, right? Bhul Bhulaiya that we call it in Hindi. Somewhere it is standing, and the goal is that it has to reach at that. The robot does not have a map. No one tells it where to go. So it takes a step forward and it hits the wall. Okay. Okay, it got a reward, which is a negative reward. So ouch. Okay. It takes a step to the right, nothing happened. It takes a step to the floor, and it takes. Oh, okay. It takes another step, and the floor lights up, which is a reward. It's a positive reward. That's how you system it. I mean, for a machine, you don't have to give them a literal money. You can just tell them that this is a reward, and they'll understand. The robot starts smiling. Well, in code, it's learning. That's reinforcement learning. It's something very similar in animals as well, or in humans as well, for that matter. If you reward the good behavior and you punish the bad behavior, or if you don't reward the good behavior, it's more than enough. It's a very good lesson in parenting as well. You don't have to scold them as well. Reinforcement learning would, if you do good, you just reward them and they will keep doing it. So that's reinforcement learning. So what is reinforcement learning? It's learned by doing, by trying, by failing, by getting rewards or punishment and figuring out what works. Again, I'll suggest a YouTube video, Cold Fusion. Are you guys familiar with it? No, right? He makes excellent videos on it. What I'll do, I'll share you
Which video?
Cold Fusion. Okay, I'll share a few videos. I'll just in case I don't forget it, I'll put it in the chat. Here's the best video on YouTube on AI. It's not algorithm related. It's more like what is the history. So you'll be more interested, like how things work, how machine learning. There were instances where using reinforcement learning, the game was on and the machine started understanding, and overnight it became really good. So that also helped the developers in creating new levels in the game. So that's how it happened. It's kind of learning we all do naturally. When a kid touches a hot pan, they learn not to do it again. Okay. When dog gets treat for sitting, it starts sitting a lot more. Machines can do the same. Why reinforcement? Because every action gets feedback, positive or negative. The feedback is called reward. The machine job is to figure out what sequence of action gets me most reward over time. It does not memorize answer, it learns strategy. Okay. A real world analogy, playing a video game. Imagine you are playing Super Mario. The first time you fall into holes, you bump into enemies. But slowly you learn when to jump, where to run, and how to win. Okay, you are not memorizing. You are adjusting based on the result. That's reinforcement learning. Now imagine a bot doing the same thing, but thousands of times faster and never getting bored. That's how machines are now beating humans in games we thought were unbeatable. Okay. Now key term, simple version. Let's keep it right. Okay. Agent, the learner, our robot or AI. It's called the agent. Environment, the world it lives in. It. The maze, the game, the role. Action, what the agent does. Reward, the score it gets, good or bad, or after taking an action. Policy, the strategy it develops over the time. Okay. The goal is to get maximum reward. Did you get it? Okay. There are three kind of learning: supervised, unsupervised, and the last one is reinforcement learning. Reinforcement learning, it's more like try till you succeed, and when you sort of like there's an increase in the level, you get a reward. So that is your reinforcement learning. Okay. Let's go to another story. Okay. AlphaGo was the company that created DeepMind. It was a UK-based company, and Google later acquired it and created Google DeepMind. In 2015, Google DeepMind built AlphaGo, a reinforcement learning system that learned how to play the ancient game Go. As I mentioned earlier, that chess was breakthrough because chess had a lot of combination, but Go had a lot of combinations. It was really hard to do it with reinforcement learning. But now Go is able to beat world champions. No one thought a computer could beat a Go champion. The game was too complex. But AlphaGo did not just study modes; it played millions of games against itself, learning from every win and loss, and in 2016 crushed the world champion. That's reinforcement learning at its best. Now, where it is used, self-driving car. Learn how to drive safely by trying things in stimulation. Okay. Teach a robot to walk, pick things up, or open doors. Finance. Learn how to buy or sell stock based on reward signal. Okay. Game AI from chess to Dota, RL bots are everywhere. Which is reinforcement learning bots are everywhere. Now, the problem is which one to use when. Okay. All right, we have met all three machine learning styles. Now imagine this is a reality show. You're the host. The problem shows up. Three contestants, supervised, unsupervised, and informants raise their hands, but only one gets to solve it. Okay. So let's figure out who learns to. Okay, let's solve it. Okay. Devesh, if you want to go up, okay. First round, recognizing the animal. You have 10,000 images of animal. Each one is labeled as cat or dog. Okay, who is raising their hand? I mean, what kind of learning would it be?
It will be supervised learning.
Supervised learning. Excellent. Okay. Supervised learning, give me the answer. I'll learn the pattern. That's what it built for labels and data. Teachers, you're labeling the data. That is supervised learning. Easy. Okay. Recognizing the crowd. Nishant, if you can help me understand this, you have customer data, but no labels. You don't know who buys what or why. You just have their behavior. They log in at 10 p.m., they log out at 11 or something like that. Okay.
Unsupervised.
What could it be? Unsupervised. Excellent. Excellent. Okay, it is unsupervised learning. I'll find the pattern of the data without needing the label. It will cluster the groups. It will find a pattern. Okay. It start grouping people on what they do, even if you don't ask it to do. It's a curious explore of the group. Okay, Krish, if you can tell me what mm, algorithm I mean learning would be here. You need to train a robot to walk, or teach a car to drive, or beat someone in chess. You know, what would it be?
Reinforcement.
Easy. Reinforcement learning. Now it thrives when the action have consequence and learning from the experience. Okay. Again, it's a cheat sheet. I don't think we need it. We are good with it. Okay. Predict tomorrow's weather is based on the past label data. It's supervised. Okay. I think okay. Discover hidden groups in social media users is unsupervised because you don't have the labels. Okay. And train a drone to land smoothly on a platform, it is going to be reinforcement. You can't define like how the level is. It is sandy, it is dusty, it has mud, does it have slope? It will keep on falling, it will keep on falling, it will figure out its own pattern. Now classify X-ray as healthy or not. Okay, supervised learning. All three learning styles is useful. None is better than other. It depends on the problem. Think of them like characters in a team. Supervised is a student with note. Unsupervised is a detective with no clues. Reinforcement is the gamer who never gives up. Together, they form a core of machine learning. Cool. Any doubt anywhere? Okay. Now let's go to the next part. Okay. So we will be creating a transform pipeline. I mean, we don't have a chance for that. So we'll do a short example on machine learning. And after that, in the next lecture, we will be using Scikit-learn. I think that should be good. Or do you guys want to finish the Scikit-learn lecture today? I am not able to hear anything. Do you guys want to finish Scikit-learn lecture today, which will be building a housing prediction model? And it will take around 40 minutes for that. Or do you want to do a small example on machine learning and continue with that in the next lecture?
I guess we'll
Next.
continue, yeah, in the next lecture.
Okay, let's just do a very small example on real world use case of machine learning. Just a second. Again, I lost it in the tab. One price. Where is the paper? Okay, we have CSV ready. Hmm. Wait, device moving. Am I sharing my screen? No, right? Just one more. Okay, the file has loaded. Sharing my screen. Is it visible?
Yes.
For some reason, my system is very slow today. Okay, we have a CSV file which has all the smartphone data. It has camera, age, RAM, the CPU score, the slot SD, SIMs, and price. Okay. let's understand this data and what we are trying to achieve. What is the problem statement? Huh. Okay. Now, when we want to solve a real-world ML problem, okay, in order to solve machine learning problem, we follow the structured approach that helps you ensure the clarity. This also need to be shared. I'll quickly share it. These are the checkpoint we should be looking at when we are solving an ML problem. I'll share it. Hey, not here. Oh. Okay, these are the what is it? I'll just quickly share it and leave it. Okay, I'll share the document, the checklist. Okay, in order to solve machine learning problem, we follow a structured approach that helps ensure accuracy, clarity, and effectiveness. Here are the main steps to involve. Look at the big picture. Understand the overall problem you are solving. Define your objective clearly. What does the success look like? Okay, that is the first checkpoint. Then get the data. Most important. Okay, collect the relevant and quality data from reliable source. Without data, there is no machine learning. You need a data, be it supervised, unsupervised, reinforcement learning. More the data you have, the more accurate your algorithm will be. Explore and visualize the data. Analyze and visualize the data to uncover patterns, trends, and anomalies. This step helps you understand what you're working with. Prepare the data. Okay, clean, transform, and format the data. Handle missing values, normalize features, and split the data into training testing set. Got it? Select a model and train it. Choose a suitable training machine learning algorithm and train it using your data. This is where your model learns from patterns. Okay. Then again, fine tune your model, optimize hyperparameters, try different techniques, improve. Then last second is present your solution, explain your model's result using visuals, metrics, clear language. So stakeholders can understand and make this clear. I'll give you an example in present your solution. Sometimes what happens whenever you're presenting your solution, it is more important. In our case, the upper management wanted to have an insight, but they already had a prejudice in their head that this is what they're expecting from the machine learning output. And no matter if your algorithm is finding out that that's not the output, so to present in a way that caters that difference, you are, let's say, the CEO of the company thinks that this is the buying pattern, and because she does not have the data to prove it, so she asks you, like, do you have the data to prove it? So at that point, visualization that does come into picture. There's a very high probability that it may align with the vision of your upper management, or it may not, or your other stakeholders. So, and if even when you disagree with, it's a visualization that will help you understand. Like these are your views. So you make your model, you make your output as per the output that is expected from the stakeholders. It's something that you'll realize once you get in the industry and start working. And sometimes people are just stubborn. They don't want to hear the truth. They just want to sort of like they only need data to back their opinion. So that's sometimes the case. So that's not correct. Okay, launch, monitor, and maintain. Deploy the model in real world, monitor its performance, and updates regular with the new data arrival. So this is the checkpoint when you try to solve a real world ML problem. And maybe if somebody can like tag the document, this that would be better. Okay. So what exact problem that we have right now? Okay, we have a CSV data, and what we are trying to solve. Okay, pandas, which is probability of random 1 to 5. Okay, the data that we have. Okay, we are creating it. Okay, we're just creating the data. Okay. Oh, sorry, my bad. This is just creating the CSV data. Okay, it's not solving any problem. So, guys, we have to get into Scikit-learn to go ahead with this. Okay, let's do one thing. Let's wrap the lecture here and we'll continue with Scikit-learn. So, what we are going to do, we have a random data of CSV, and on that, we will be running our machine learning algorithm and deduce training out of it. Okay. I think my bad. I thought like this might be a problem, but it was actually creating just a CSV. Okay. Got it? So we will continue with Scikit-learn in the next lecture. Any questions, anybody? No, right? Okay. Any feedback, do let me know. And thank you for your time. See you in the next lecture. Bye.